So hello everyone. Welcome to the FAANG course. So my name is Ratullah Edige and I'm your lecturer at this course. And in this lesson we will pass introduction to asymptotic analysis, and also we will cover the topic about Python basic concepts. So let's begin. So in this lesson we will pass what is the complexities and Pico and the notation functions, and after that Python basics, and in the end of this lecture I will give one homework. So what is Pico notation? Pico notation is some function that describes the growth of in complexity of an algorithm. So when we have some algorithm, we can estimate its time and space complexity. So in this case, we first pay attention at time complexity. So for example, we have this kind of code, and here we add some number here, so calculating something here and assigning them into some variable, and after that here we have some loop, for loop. And while in the loop we do another operation here, and after finishing this loop we return something, and in this case our time complexity will be O(n), because we do some operation here n times, because it we estimate it as O(n), and O(n) means it is the linear complexity, because it depends on input data, and when we have many input data, then we have the same number of operations. So this is the linear. And then after that we have this kind of pseudocode. Here we do some operation, so making some addition, and after that we assign its result to some variable. After that we print something here, and after that we return something here. So in this case our time complexity will be O(1), because in this case it will go through with one operation here, which is, so here we don't have any loops, so for loop, while loop, and etc., or some recursion. So because that time complexity will be O(1) here, and here is the function of O(1). So O(1) it means the constant complexity. So it not depends with the input data. So if our data is very big, so our time complexity or space complexity will not be changed. So our complexity will stay the same as the constant. So when we have this kind of algorithm, and after that here, so let's look at this pseudocode. So here we have one loop, and in this loop we have another loop. So when we have these two loops, so in this case our time complexity will be O(n) squared. So when we see its graphic, when we have more data, then and for a execution we need to have many operations. So when we have 100 data, a number of operations will be 10,000 here, something like here. And also we can see it here. For example, let's imagine that we have 10,000 elements, and if we do some operation in some algorithm where it costs O1, so it will be only one operation. When we do it in On, so when we execute some algorithm which costs On 10,000, and also when we do it in some algorithm which costs in quadratic complexity, so number of operations will be. Then if we use it in cubic complexity in some algorithms, so it will cost 1 trillion number of operations. And if we do it in some algorithm which costs n factorial, so its number of operations will be very big. So because when we have this kind of elements, we can use just On or log n. So here we have some hint. For example, when we have some problem, and we have some requirements in the problem, for example, input side requirements. So we look at the requirements, and after that we can use some required time complexity when we develop our algorithm. So we need to pay attention for these cases. If our algorithm's complexity costs O1 or O log n, it is something like good, excellent. If it's time complexity will be On, it will be fair, and log n is bad, and n square it is horrible. Our time complexity will be bigger than n squares, so it means that our algorithm is not very optimal. So when we solve some problem, we need to find the optimal one. Here are several data structures, and so we pass them in the next lectures. So in the third and fourth lectures we will have these the topics, which is array, stack, queue. So here we have some table where we can estimate the complexity when we use some functions. Here, for example, when we use some array, so we can access its elements by its indexes. So it costs only one operation. But when we need to search some element in some array, so we need to check every element. So it will be On, and insertion also On, deletion On. So it is something like this. So let's continue with Python basics. So in Python, for example, I want to show that list and tuple and dictionary sets, so we can use them. So here, for example, I have some file list, so I will share this file with you. So we can create list something like this. After that, we can create an empty list, and we can create a list with different data types in Python, so something like this. And we can allow duplicates in lists. We can access first element with 0 and last elements with the minus sign. And what else? And we can change some elements in the list by the given index, and etc. And also we have a tuple. So what is tuple? Here we have tuple. But so the main difference between tuple and list is so in list we can change some elements, but in tuple we cannot change it. So it means that tuple is immutable, so and list is immutable. So why do we use tuple in some cases? Because tuple is more faster when we use it. So here is some code, I will show it here. So I think here in the end we have some here. So we can compare tuple and list. when we have here list and tuple, we can count their times. So here I count their size, print, and after that time. So here we create some array and tuple. Here we compare the execution time of list and tuple creation statements, and here's the result. In list we spend this kind of time, in tuple we spend here. So it is, when we have this kind of element, it is 12 times faster to create this kind of tuple. So when we have the bigger size of tuples, so in that case we can save lots of times by using tuple. So here is the basics of tuple, and so basically both of them are simple, and in most cases both of them are the same. So in some cases they have some their advantages and disadvantages. And also in the dictionary set. So I will share also this file with you. So basically we will pass them in the certain fourth lecture more deeply, and we will solve some problems at that time. So in this lecture I'm showing you some basics of them. So they are, I think, not very hard to learn. And lastly we have object. We can use object when we work with some tree and graph, and also in linked list. For example, in Python, when we use some linked list, we need to create some class objects. So in class we will have some value and next pointer. So in this case we need to create some object. And also when we use some graph, so we need to use its connections, and we can use some value and connections as the class attributes. So in that case we need to use some object. And also in tree, so when we use some binary tree, we need to have some left and right childs. So for use some tree node, we can use also object. We can pass them trees and graphs later in 9th week here. And in that I want to give some homework. So the homework is about CV. In the next lecture we will pass the CV screening.